Hello everyone, this is Aditya from ACE Academy. In this video, let us look at Civil Engineering GATE 2021 Mathematics questions. Now from both set 1 and set 2, there were 9 questions each. 5 1-mark questions, 4 2-mark questions. Let us look at their solutions. Let us look at set 2 questions. The smallest eigenvalue and the corresponding eigenvector of the matrix respectively are dash. So, it's not just asking what is eigenvalue and eigenvector. You are supposed to find the eigenvalues, among them the smallest eigenvalue, corresponding eigenvector. So, first thing is find the eigenvalues. See what is the smallest eigenvalue. Let's have a look at this. How do you find the eigenvalue? We write the characteristic equation. Let's write the characteristic equation, get the characteristic polynomial, get the roots of that polynomial, right? So this is the characteristic equation. I have simplified this. I have got a quadratic equation, that is lambda square minus 8 lambda plus 10 equal to 0. This is in the form of ax square plus bx plus c. If you want to find the roots, and it is minus b plus or minus root of b square minus 4ac by 2a. You use that formula, get the roots. The roots are 4 plus root 6, 4 minus root 6. Among 4 plus root 6 and 4 minus root 6, which is the smallest one? Obviously, 4 minus root 6 is the smallest one. 4 minus root 6. Approximate, 4 minus root 6 value is 1.5505, right? Let's look at the options. In the options, clearly I can eliminate 2. So now the answer is among B, C, D, right? So there is only one correct answer. It's a multiple choice question. So you can now go for verification. Why verification is? Some of you might be asking, sir, we have got the eigenvalue. Why don't you find the eigenvector? You can do that, but eigenvalue, if it was integer, then our calculations would have been simple. This is not an integer, right? You will have to do some mathematics. Instead, you go for verification. What verification you have to do? You have to look at what is, you have to go for this kind of verification, that is ax is equal to lambda x. For example, let's look at option B. I'll set lambda as 1.55 and the eigenvector x as 2 and 0.45, and then I look at what is ax, what is lambda x, are they equal or not? If they are equal, then that would be our right answer. So let's do that verification now. So I have taken option B. So this is eigenvector, this into this 0, this is a column. So 2 into 2 is 4, minus 2 into 0.45 is 0.9, and then if you do the simplification, this is 3.1. This is minus 2, and then 6 into 0.45. You need to use your virtual calculator. So this gives you 0.7. Now, if you put 1.55 out, then what you get is again 2.45. So this looks like ax. This looks like lambda into the same x. That means this is our right answer. This is a multiple choice question. If it was multiple select question, then you have to verify the other options. But this is a multiple choice question. Only one answer. So what do you think is the answer for this question? It is option B. So now I can set this and go to the next question. So let's go to the next question. Have a look at this question. The rank of the matrix is dash, right? Again, it's a very simple problem, a very standard model. Let me count the rows. 1, 2, 3, 4. 4 rows. Let me count the columns. 1, 2, 3, 4. 4 columns. So it's a 4 cross 4 matrix. What you are supposed to do is, you have to reduce this to the row echelon form and then count the number of non-zero rows. That's simple. So for that, what I'll do is, I'll use this and make this element 0. I'll use this, I'll make this element 0, because if you do this way, you are reducing the matrix to row echelon form. So what are the equations that you have to write? You can write R3 is R3 plus R1. Now here you can see 2, here you can see 1. So you can now say R4 is R4 minus 1 by 2 R2. Let's do those steps. Have a look at this. R3 is R3 plus R1 because minus 5 plus 5 gives you 0. Na? R4 is R4 minus 1 by 2 R2. So after this, what you get is this. Here itself you can comment about the answer, It's like this entire row is 0 now. You can interchange this with this. And if you try to look at the resultant matrix, that resultant matrix is in row echelon form. So how many non-zero rows are there? There are 3 non-zero rows. So what do you think is the answer? The answer is rank of this matrix is 3. So the rank of the matrix is 3. So we are done with this problem. Let's go to the next one. Let's look at this problem. What is he asking? He says a function is defined in the Cartesian coordinate system as f of xy equal to x e power y. So it's a scalar function. The value of the directional derivative of the function at a point 2, 0 along the direction of the straight line segment from 2, 0 to 1 by 2, 0. So how much would be the value of the directional derivative? Again, a standard question. What is the directional derivative of a scalar function at a point P along a vector a bar? Let's have a look at this. You would have studied this, na? The directional derivative of a scalar valued function at a point, let's say P, in the direction of a vector is given by the following. Right? It is given by what? Gradient of f at that point dot product with the unit vector, right, along a bar. So what are the things that you need to find? You need to find gradient f. Substitute the point P in that. Should also find the vector a bar. And after that you have to get the unit vector along a bar. So let's do it. So how do you find the gradient? How do you find the gradient? Have a look at this. I have the scalar function in front of me, that is x e power y. How do I find gradient? Gradient of f is I dou by dou x of f plus j times dou by dou y of f plus k times dou by dou z of f. Since there is no z involved, I just write it as I dou f by dou x plus j dou f by dou y. Substitute f here, take the partial derivative. The partial derivative of this with respect to x is e power y. The partial derivative of this with respect to y is x e power y. So you have to see, you already know, right, partial derivative. When I take the partial derivative of this with respect to x, I will treat y as constant. So I have got gradient f, substitute that point. Which point? 2, 0. So what you got is 1 plus 2j. Now you need to get the vector, that is a bar. So how do you get that vector a bar? So again, I'll read the question for you. Have a look at the question. Along the direction of the straight line segment from the point 2, 0 to 1 by 2, 2. So you have to find a vector where it is along the line joining the 2 points. So this is something like x1, y1. This is like x2, y2. So if you have to find a vector along this, it is simply x2 minus x1 times I plus y2 minus y1 times j. So that would be the vector. And after that, you have to find the unit vector. Here I have vector along the direction of the straight line segment from 2, 0 to 1 by 2, 2. I have got this. This is a bar. Now what? The last step, that is the directional derivative of the scalar function f at point P in the direction of this vector is simply gradient f dot product with the unit vector. So do this simplification. Finally, you see that the answer for this question is 1. Let's see the next problem. This is a very standard model. You would have, so whoever is preparing for GATE would have definitely solved this kind of problem in their preparation or during their preparation. Let's look at the next problem. the unit normal vector to the surface at the point 4 comma 4 comma 4 is dash. See here, unit vector of a sphere, we frequently use it, right? We frequently use it. So I have taught for many students. So now that is very much in my brain. So the unit vector, the unit normal vector to the sphere is simply xi plus yj plus zk by the radius of the sphere. Now if you do not know this, then what you can do is, you can first write equation of the equation of the surface, that means that is related to sphere, and then try to look at the unit normal vector to that surface. So let's get into the discussion. So let's look at what do we have now. The unit normal vector to the surface phi, not just sphere, you take any surface. How is that given? It is given by gradient phi by magnitude of gradient phi. What is phi? Phi is the surface equation, right? So now instead of this phi, we have this x square plus y square plus z square equal to 48. Now if you bring that 48 the other side, you have something like x square plus y square plus z square minus 48. So whichever points that lie on the sphere are going to satisfy x square plus y square plus z square minus 48 equal to 0. So let's continue the discussion. Let the surface equation be this. So whichever points that are on the sphere are going to satisfy this, na? Right? So now you have got phi, find gradient phi. So the gradient phi is the partial derivative of this with respect to x. So I times the partial derivative of this with respect to x plus j times the partial derivative of this with respect to y plus k times the partial derivative of this with respect to z. Then find its magnitude. So 2x whole square, 4x square plus 4y square plus 4z square, and then you got the under root. What is common? 4. Put it out. Twice of this. Now, are you on the sphere? Of course. Where are you finding the unit normal vector? Unit normal vector is calculated on the sphere. If you are on the sphere, any point on the sphere is going to satisfy this. X square plus y square plus z square equal to what? R square. So now instead of this, that is, I can put r square, square and root cancel, what I get is 2r. Let's put the last step now. So what is the unit normal vector? It is simply gradient phi by magnitude of that. So 2xi plus 2yj plus 2zk by magnitude is 2r. 2 cancels. It is xi plus yj plus zk by r. Not just for this gate. It has been asked in the previous years as well. Not only here this unit normal vector while finding the surface integrals, right? It's a usual practice to find the unit normal vectors while finding surface integrals. So you should be thorough in that. So in the exam, you need not do all these calculations. During your preparation, if you would have calculated the unit normal vector of a sphere, then it's a fraction of second answer for you. So what's the final answer? It is xi plus yj plus zk by r. What is that point? 4 comma 4 comma 4. So it is 4i plus 4j plus 4k by r. R square is 48. R is root 48. So root 48. 48 can be written as 16 into 3. So root 16 is 4. 4 cancel. It is I plus j plus k by root 3. I plus j plus k by root 3. This is a vector. Now sometimes this can be represented in the point form as well. If you represent this in the point form, then you get 1 by root 3 comma 1 by root 3 comma 1 by root 3. That is option A. So we are done with this question as well. Let's look at the next problem. What is he saying? If k is a constant, the general solution of this differential equation will be dash. Now when I read this, this reminds me about dy by dx plus py equal to q. Dy by dx plus py equal to q, where p and q are functions of x. If you compare dy by dx plus py equal to q, in the place of p I have minus 1 by x. In the place of q I have 1. So now it's a very standard differential equation. So you have to find the integrating factor. The integrating factor is simply e power integral p dx. We also have the direct solution for this, right? So let's look at this. Let us write it. See here, I compared this with this, got p value as what? Minus 1 by x. Now the integrating factor is e power integral p dx. When I substitute this, the integration of 1 by x is log x, and there is a minus sign. So I take minus sign inside, I get log 1 by x. E power log 1 by x is simply 1 by x. Finally, what is the integrating factor? The integrating factor is 1 by x. It's a first order linear differential equation. This is usually called as Bernoulli differential equation. Its solution is readily available to us, right? So many times during your preparation, you would have solved and you would have written the general solution as y into integrating factor equal to integral q into integrating factor dx plus constant. That's what is written. Y into integrating factor, that is y into 1 by x equal to integral q, which is 1 into 1 by x dx plus k. Since 1 by x integration is log x, what I'll do is I'll treat this constant also as log k, right? Log k is also a constant, so there is no harm in it. Log x plus log k is log xk. Log a plus log b is log ab. So now y by x equal to what? Log xk. Now you rearrange. So what is the answer? If x goes this side, y equal to x log xk. Let's look at the options. Y equal to x log xk, that is option C matches. Let's go to the next problem. If A is a square matrix, then the orthogonality property mandates, if you have like a basic idea about what is an orthogonal matrix, then there's going to be very simple answer for this. So now I remember that a matrix is said to be orthogonal whenever it satisfies the following condition, that is A into A transpose equal to A transpose into A equal to I. Right? Now is there any option that way? A into A transpose equal to I. Yes. So this and this, if you look, this is what is given in option D. This is also a multiple choice question. Only one answer is correct. A into A transpose equal to I is the condition for a orthogonal matrix. So the answer for this question is option D. That's what I've been telling you. Such a simple problems are asked, right? Difficult problems are also asked, but if you can solve these first and then the difficult ones, that's how you can improve your marks. Let's look at another question. Numerically integrate f of x from lower limit 0 to 0.5. Use trapezoidal rule with 5 equal subdivisions. The value obtained is dash. He gave us some function. He is asking you to numerically integrate it using trapezoidal rule. Right? In the set 1 also, a question appeared from this topic. So how many subintervals? So let me highlight the keyword here, 5 subintervals. You have the function with you, right? So what you do is, you now create the table, right? So 0 to 0.5, divide that into 5 subintervals, equal subintervals. And then see what are the x values and what are the y values. So let's look at that. Have a look at this. First thing is, I have highlighted the trapezoidal rule formula, right? So if you are interested in finding area under the curve using trapezoidal rule, then it is given by h by 2 plus y naught plus yn plus twice the remaining samples. What is n here? N stands for number of subintervals. Number of subintervals in the problem is 5. So now, do the this table part calculation. So 0 to 0.5, na? I need 5 subintervals. For 5 subintervals, we need 6 points here. So I'll start with this 0, 0.1, 0.2, 0.3, 0.4, 0.5. What is the interval length? 0.1, 0.1. All are equal length. How do you find the functional value f of x? f of x is given as what? 10x minus 20x square. 10x minus 20x square. How do you find y naught? Y naught is simply substitute x naught into the function. That is 10 into 0 minus 20 into 0 square. Obviously that would be 0. In the same way, find y1. How do you find y1? 10 into 0.1 minus 20 into 0.1 square. Use your virtual calculator. Fill this table. Once you fill this table, put all the values into the formula. So when you put this, what you get is 0.4. So the answer for this question is 0.4. Let's look at another problem. The value of this integral is dash. Have a look at this integral. Minus 1 to 1 x e power mod x. The nature of x is odd. The nature of e power mod x is even. The nature of x e power mod x is something like an odd function multiplied with an even function will give you an odd function. For example, x square is an even function. X cube is an odd function. Go for the multiplication of these two functions. X square into x cube is x power 5, which is an odd function. Right? Now, the area under an odd function, from minus 1 to 1 will always be 0. Area under an odd function from minus a to a is always 0. So because of that, this is 0. The answer for this question is 0. So like I have mentioned, x is odd, e power mod x is even. The product is again an odd function. So area under this would be what? 0. Let's look at another problem. The value of limit x tends to infinity x log x by 1 plus x square is dash. Now first substitute the limit. See what form are you getting. Now when I substitute, this infinity goes here, infinity goes here, infinity goes here. So this gives me something like infinity into log infinity by 1 plus infinity square. So which is in the form of log infinity is infinity. 1 plus x square, that is 1 plus infinity square is also infinity. So this gives you infinity by infinity form. If it is infinity by infinity form, you can use L'Hospital rule. What is L'Hospital rule? Take the derivative of the numerator, derivative of the denominator, and then substitute the limit. Let's do that. Have a look at this. So this is the function. I have got infinity by infinity, which is an indeterminate form. Derivative of the numerator. So this is something like uv. So x into the derivative of log x is 1 by x plus log x into the derivative of x is 1. That's what is written here. And the derivative of the denominator is 2x. This cancels. Here you have 1 plus log x by 2x. Substitute the limit. 1 plus log infinity is again infinity. 2 into infinity is again infinity. This is giving you infinity by infinity form. That is an indeterminate form. Use L'Hospital rule. If you use L'Hospital rule, the derivative of this, because this is 1, the derivative of constant is 0. The derivative of log x is 1 by x. So in the numerator you have 1 by x. In the denominator, the derivative of 2x is 2. So finally what you have is 1 by x by 2. Now when x is tending to infinity, 1 by x tends to 0. So the answer for this question is 0.